Thank you for joining today's webinar. The primary goal for this presentation is to provide information regarding product offerings that have been designed to meet the USP 232 and ICH Q3 specifications for impurity testing. We will also touch briefly upon the criteria that have been used to design these products and provide some tips regarding element compatibility and solution stability. The presentation is relatively short, approximately 12 minutes, and if you have any questions regarding the material presented, please contact the technical support team at Inorganic Ventures. Additionally, this presentation is posted on our website for future reference. It is appropriate to spend a little bit of time discussing the background of USP 232 and the ICH Q3D specifications. The initial specifications from 2012 and 2013 have changed significantly, and this has impacted how Inorganic Ventures has designed appropriate reference materials. The good news is that from 2015 onward, the USP specifications have not changed. And as of 2016, USP has included the 9 additional elements that are part of Q3D. Shortly thereafter, in 2017, both USP and the ICH specifications became fully aligned. With regard to the initial stock product offerings Inorganic Ventures produced when USP was originally proposed, this product list grew and evolved over several years to meet customer requests. And as time passed and the USP limits changed, we responded with new stock products accordingly. It was during this evolution that we began to develop an appreciation for the significant variability in what reference material users were looking for with respect to complying with impurity testing directives. The more recent agreement between the USP and ICH specifications has brought much needed clarity to the issue. As a result, we created 6 stock products in 2018 that are fully consistent with the 232 and Q3D specifications. And now what we want to do is to look at these products in more detail in the next few slides. One simple way to describe these product offerings is to use the tables provided by USP and ICH as part of their documentation. Many of you may be familiar with the tables describing the concentration limits or permitted daily exposures for the 24 elements covered by these methods. The data table on the slide corresponds to Table 1 of the final USP 232 publication and Table A21 in the appendix of Q3D. We have based our product offerings upon the element classes described in both methods. 5 of our more recent product offerings are outlined in the table, with the acid matrix for each product listed as well. One product worth noting is IV Stock 58, where silver was separated from the other Class 2B elements for compatibility reasons, and we will discuss those particular reasons in more detail shortly. We also want to point out that the Class 3 elements as part of the IV Stock 69 product represent element concentrations that are 10 times lower than specified in the table. The primary reason for this is that there are long-term stability concerns when considering concentrations that are well above 1,000 parts per million for this particular mixture of elements, and we will discuss our design criteria in just a moment. The 6th product that we introduced in 2018 is based upon the limits described in Table 3 of USP 232, which corresponds to Table A22 in the Q3D method. This data table represents the individual component approach described in 232, which is also known as Option 1 in Q3D. This particular product, IV Stock 70, represents a combination of all 24 of the elements specified in the methods. And this is possible due to the lower concentrations that are detailed for the Class 3 elements. This is the only product that we are currently offering as a stock that is not based directly upon the permissible daily exposure table. It primarily reflects the number of unique requests that we have observed for these element concentrations, which we will discuss in more detail in the next slide. For the design of our stock IV products, over the past several years, we have received many requests for standards related to 232 and Q3D. The information presented on this slide is just a summary of the variability that we have observed. We have over 50,000 unique custom standards in our database, and if you screen these requests for elements and concentrations related to 232 and Q3D, there are well over 100 unique formulations that people have asked for over the past years. The variability frequently results from the omission of certain elements or for concentration requests that reflect multiples of the method-specific concentrations. And what we have observed is that most end users are focused on the oral permissible daily exposure limits, with fewer requests for the parenteral specifications. However, many of the combinations of parenteral limits are already captured and approved for manufacturing in our database. So if you have specific requests regarding the parenteral limits, please let us know. Next, we want to provide a little bit of information about the criteria that we have used for designing these products. The next slides are going to focus on chemistry and the criteria we follow during product design. These include the stability and compatibility of the elements and matrix. It is also important to consider the safety aspects of any particular combination, and please observe that we have specified osmium in the slide. It is also important to note that our goal is a shelf life of at least 4 years for all products, and each of the stock products described in this presentation have a 4-year shelf life. The periodic table lists all 24 elements that are part of the methods and the stability compatibility concerns that are worth noting. For this particular slide, we are focusing on nitric acid matrices. And while all of these elements can be prepared in nitric acid, the significant safety concerns regarding the volatility of osmium as a tetroxide argue against this approach. Also, for some precious metals, it is simply not possible to avoid including chloride for stability. And this can create real problems, as silver is one of your elements of interest. Another popular matrix that people frequently use is hydrochloric acid. And if we consider the stability and compatibility of these 24 elements in an HCl matrix, overall, hydrochloric acid is a better choice, particularly if you are required to test for all the Class 2B elements. There are concerns about silver stability, but this issue can be avoided if the acid to silver ratio is high enough. A good rule of thumb is that 10 ppm of silver requires 10% HCl to remain stable. It is important to note, however, that the photosensitivity of silver in an HCl matrix must be accounted for, and the remedy for that issue is to avoid exposure to light. And just as a reference, if you take all 24 elements that are specified in the two methods, and they are present at concentrations of 100 parts per million, we have a mixture that has a demonstrated stability that exceeds 4 years in an HCl trace HF matrix. So you can use that as a point of reference if you are preparing the standards yourself in your own lab. The information on this slide and the preceding slide are captured in a white paper that is available in the Education Center of our website, and you can reference that as well. Finally, what we want to do is talk a little bit about the preparation tips for the 232 and Q3D elements. There are numerous details related to these elements and the possible combinations and applications of the impurity testing methods. So we'll focus on just a few of the broader suggestions regarding the stability and compatibility of these products. One thing that's important to note is our criteria for a multi-year shelf life. This does not apply to diluted working standards. Many of the restrictions imposed by a long shelf life may be disregarded for the preparation of diluted standards that you are going to use relatively quickly. Another suggestion is that if you can avoid testing for osmium, please do so. It will simplify many of the aspects of the analytical process, from sample preparation to measurement. Many of the technical questions that we receive are related to the measurement of this element, and we would be happy to provide more information if you have to measure osmium. Other than osmium, the two elements that are most likely to present analytical challenges are mercury and gold. and this is going to be particularly true if your process requires the use of a nitric acid matrix. We have a great deal of information on our website regarding the stability of these two elements in nitric acid. Briefly, if you do need to measure both mercury and gold, we would recommend HCl as the matrix for your final dilutions. And if you have any other questions, please don't hesitate to contact us. Lastly, we just want to point out that if you are preparing your own mixtures and you need to analyze thallium as part of the Class 2B elements, please just make sure that your starting material ensures that thallium is in the +3 oxidation state, or precipitation as a chloride salt can occur, particularly if the precious metals are part of your analysis. Simply put, thallium will behave just like silver if it is in a +1 oxidation state, and you can run into problems if you're measuring the 2B elements such as osmium and the precious metals and you want to include thallium as part of that measurement. So this was just a quick overview of the products that we offer for the USP 232 and ICH Q3D specifications. Hopefully, the information provided here today will be useful. We are available to provide additional information regarding the analysis and sample preparation for these methods, and as always, free technical support is available to everyone. We ask you to contact us by email, phone, or whatever method works best for you, and we will be happy to help you out as best we can. Thank you for your time.